Hello everyone. Today we would like to talk about Sustainable Development Goal 7, which is affordable and clean energy. First of all, energy is a very important part of our daily life. Usually we use electricity for lighting, air conditioners, computers, projectors and many other devices, especially in places like universities and office. Without energy, daily activities cannot run smoothly. However, as energy use increases, problems such as high electricity bills, energy waste, and carbon emission also increase. Because of this, it is important for us to use energy wisely and efficiently. This is why SDG 7 plays a very important role in creating a more sustainable future. So, why we choose SDG 7? First of all, SDG 7 focuses on making sure that energy is affordable, reliable and clean, which also encouraging efficient energy use. Using energy efficiently can help reduce the unnecessary electricity consumption. So basically, when there is less energy is used, electricity costs will become lower and there will be a fewer fossil fuels are burned to produce electricity. This directly helps to reduce carbon emissions and protect the environment. So, for example, in places such as universities and offices, energy will be used every day for a long hours. By improving energy efficiency, this institution can save money, reduce environment impact, and support long-term sustainability. Therefore, SDG 7 is not only about energy access, but also about responsible energy usage. So, for the identified problem, even though SDG 7 is a very important thing, there is still a big problem in many buildings today. For example, in offices and universities. In these places, electrical devices are often left on even when they are not needed. For example, air conditioners, lights, computers and lab equipment may continue running after office hours, during breaks or when rooms are empty. This causes a lot of unnecessary energy waste every day. This problem happens mainly because people do not know their real-time energy use. Most users do not realize how much electricity they are using at a certain time. They also may not understand how simple daily habits such as leaving devices on can increase energy use and carbon emission. Because of this, electricity usage becomes very high. High energy use leads to higher electricity bills and higher operational costs for institutions. At the same time, more electricity production means more carbon emissions, which harms the environment. Over time, this energy waste goes against the goals of sustainable and clean energy.
Assalamualaikum and good day everyone. This presents summaries finding from the survey on electricity usage awareness and carbon footprint involving 34 respondents, mainly students. First, awareness of environmental impact. About 67.6% of respondents are aware that electricity usage contribute to carbon dioxide emission, while 20.6% are not aware and 11.8% are unsure. This shows that although awareness is generally high, a significant portion still lack clear understanding of environmental consequences of electricity consumption. Second, understanding of carbon footprint. Only 55.9% of respondents know what is carbon footprint is, where 32.4% do not, and 11.8% are unsure. This indicates that awareness exists, but the conceptual understanding of carbon footprint still need improvement through education and exposure. Third, electricity usage behavior. In terms of good practice, 55.9% always switch off electrical appliance, 38.2% do not sometimes, and 5.9% rarely do. However, despite this, 61.8% admit they have left appliance switch on, not necessarily highly a gap between awareness and actual behavior. Fourth, acceptance of monitoring system. A strong 70.3.5 believe that real-time electricity and carbon dioxide monitoring system would help reduce energy wastage, showing high acceptance of technology-based solution. Finally, implementation preference. About 70.6% prefer the system to be implemented everywhere, including university and resident homes, indicating the needs of widespread adoption rather than limited deployment. In conclusion, the results show good awareness but inconsistent behavior and strongly support real-time monitoring system as an effective tool to reduce electricity wastage. Thank you.
Now I will explain our proposed solution and prototype. Our solution is a smart carbon footprint monitoring system for buildings. The main purpose of this system is to track electricity consumption in real time and estimate the carbon emissions produced by that energy usage. So, the system works by monitoring how much electricity is used by building appliances such as air conditioners, lights, computers, and so on. The collected data is then processed by microcontrollers and the results are shown to users through visual indicators or a display. By making energy users visible, users become more aware and are encouraged to reduce unnecessary consumption. To demonstrate this concept, we developed a prototype using Tinkercad simulation. In this simulation, we use an Arduino Uno as the main controller of the system. A potentiometer is used to simulate energy users in a building. When the potentiometer is rotated, it represents an increase or decrease in electricity consumption, similar to appliances being turned on or off. The Arduino reads the input value from the potentiometer and converts it into a simulated energy consumption value. Using a predefined carbon emission factor, the system then estimates the amount of carbon dioxide emitted based on the energy used. The output of the system is shown using LED indicators. A green LED indicates low energy consumption, a yellow LED indicates moderate, and a red LED indicates high energy consumption. For example, when energy usage is low, the green LED turns on. As the energy usage increases, the LED changes from green to yellow and finally to red. This provides immediate visual feedback to users about their energy consumption level. This prototype clearly demonstrates the relationship between energy usage and carbon emissions. Although this is a simulation, the same concept can be applied in a real building by replacing the potentiometer with actual energy sensors and connecting the system to a real monitoring dashboard. So, in summary, this prototype shows how real-time energy and carbon monitoring can help reduce energy wastage and support SDG 7, which is affordable and clean energy.
Assalamualaikum and hi everyone, my name is Khairul Nazrin Fahmi and I'll be presenting about the contribution of our smart carbon footprint monitoring system which will contribute to Sustainable Development Goal 7, which is affordable and clean energy. And then I'll also be presenting about the economic, social and environmental impact of our system. So firstly, the smart carbon footprint monitoring system will contribute to Sustainable Development Goal 7 by promoting efficient energy use in institutional buildings such as universities and office. Through real-time monitoring of electricity consumption, the system helps identify and reduce unnecessary energy usage, particularly from appliances that are left running for extended periods when not needed. By encouraging more responsible and optimized energy consumption, the system directly supports SDG 7's objective, which improving energy efficiency while ensuring long-term energy sustainability. We move on to the economic impact. So from economic side, the systems help reduce electricity bills by identifying energy wastage and also abnormal consumption patterns within buildings. With real-time data shown by the monitor, building managers can take immediate corrective actions to prevent excessive energy use, which would otherwise increase operational costs. Over time, the system also lowers maintenance expenses, by reducing the strain on electrical appliances and equipment, contributing to more cost-effective and sustainable building operations. We're moving on to the social impact. The system increased energy awareness among users such as students, staff, and office workers by providing clear visualized data and timely alerts. This encouraged responsible energy-related behavior, including switching off unused appliances and optimizing daily energy usage. As a result, it fosters a culture of accountability and shared responsibility, where individuals become more conscious of their energy consumption and its wider impact. And lastly, from the environmental side, our carbon footprint monitoring system will minimize unnecessary electricity consumption, and the system will effectively reduce carbon emission associated with energy generation. This will lead to a lower overall carbon footprint for buildings, helping to address greenhouse gas emissions. Consequently, the solution supports climate change mitigation efforts and contributes to the conservation of natural resources. And that's all from me. Thank you so much.